Chapter 5, Covalent Bond. Before we talk about the formation of a covalent bond, let's briefly go through the key differences between ionic and covalent bonding. Number 1, ionic bonds, metal, nonmetal, covalent, both nonmetals. Ionic electron transfer, covalent electron sharing. Ionic compounds do not have molecules. Covalent compounds, however, always have a few atoms combined together to form a new particle unit, which is called a molecule. Ionic compounds are solids at room temperature. Covalent compounds may be solids, liquids, or gases. Soluble ionic compounds, once they're dissolved in water, the solution are good electricity conductors. Soluble covalent compounds, however, usually their solution do not conduct electricity. Usually, there are exceptions though. Covalent bond is a chemical bond resulting from two nuclei attracting the same shared electrons. So there are some electrons that are shared between two atoms. The two positively charged nuclei are attracted to the shared electrons in between. By doing that, they're bonded together. Let's use hydrogen molecule to talk about the formation of a covalent bond. Do you remember the substance we used when we described the formation of ionic bond? Yes, sodium chloride. That's what we used. Okay? We started with the loose symbol of sodium and the loose symbol of a chlorine. Two atoms by themselves, neither of them is happy because they do not satisfy the octet rule. One day they come across each other. Chlorine, the nonmetal, grabs the electron from the metal. Metals are losers. Sodium loses one electron. The next electron shell, shell number 2, becomes the outermost shell, which has 8. So sodium becomes positively charged but satisfied the octet rule. Chlorine, the outermost shell, now got 8 electrons. It carries a negative charge, positive and negative, they attract each other, an ionic bond is formed. This is the Lewis structure of sodium chloride. Now let's move to hydrogen. Let's see what they're going to do to form a bond to become more stable. So we have two hydrogen atoms. Neither of them is happy. They're not happy because they do not satisfy the octet rule. Please be reminded, the octet rule for hydrogen is not 8, it is 2. The noble gas right next to hydrogen is helium, which has 2 electrons in shell number 1. So the goal for hydrogen to become more stable is not 8, it's to get 2 electrons in its shell number 1. So neither one right now is happy by itself because it has only 1 electron until one day they come across each other. They look at each other, they know each one is going to need 1 more electron. However, they look at each other to realize that they cannot fight for electrons. They are both nonmetals. Metals are losers. Nonmetals do not get electrons from other nonmetals. They can only share. All right, so they look at each other. They do not want to lose the opportunity to become more stable. As a result, they go closer and closer, move closer and closer, until at a point, the two merge in together. The two merge into one unit, and they put both electrons in the middle between the two nuclei. a hydrogen molecule is formed, a covalent bond is formed. Electron sharing can occur only when electron orbitals from two different atoms overlap. So here is the orbital overlapping. Okay. It produces increased stability because they both have two electrons in their outermost shell now. This or this is called the Lewis structure of hydrogen molecule, using a dash to represent shared electrons in between. All right, here it used the Lewis symbols of hydrogen to represent the process of the formation of a hydrogen molecule, similar to the one we did for sodium chloride. All right, here we have a shared pair of electrons. This is called the Lewis structure of hydrogen. Again, a pair of shared electrons can be represented by a dash between two atoms.